In this video, we'll be looking at isotopes and average atomic mass. So first off, isotopes, they are elements of the same kind that have different atomic masses. So if we consider these two representations of atoms, they're both going to be chlorine, and that's simply dictated by the number of protons. They both have 17 protons, they're both chlorine atoms. However, they have different overall atomic masses because this particular isotope has 18 neutrons and this other one has 20 neutrons. So if I were to name this isotope on the left, I could call it chlorine 35, and I get that 35, that is the mass number, and that is the number of protons plus the number of neutrons. Protons carry a mass of 1 atomic mass unit, so do neutrons, and their sum is the mass number. So over here, this one's going to be called chlorine 37, and that's because the 17 protons plus the 20 neutrons gives you a mass number of 37. Another way that you may see isotopes represented are with just symbols, and so what you might see is 37 over 17 Cl. That 37 is of course the mass number, the 17 is the atomic number, which for all chlorine will be 17, and then you can have the symbol right there. So those are the two primary isotopes of chlorine. Now, if you were to look at the sample, you could count up all of the atoms here and find an average atomic mass. So what we could do is we could say this one is apparently the 35, and this is the 37, and we have the 35 here again, 35, 37, 35, 35, and 35. And so we have 1, 2, 3, 4, 5, 6 atoms of chlorine 35 and 2 atoms of chlorine 37. And yes, it would be possible to multiply 6 times 35 and add 2 times 37 and take that and divide by the 8 atoms. So this would be your total mass divided by the number of atoms. That would give you an average, but this isn't a practical thing because atoms are too small to count. And so instead what we'll do is we'll use what's called a weighted average to figure out the average atomic mass of all chlorine, not just 8 atoms. As it happens, those 8 atoms are pretty close to the distribution that you get if you were to just take lots of chlorine and figure out their average mass. But again, we can't count individual atoms just because they're too small. So we'll use what's called a weighted average. So what is a weighted average? Simple averages you probably learned a long time ago in math. And a weighted average is just an extension of the simple average. Let's consider this. If your grade in another class had 4 equally weighted categories, and those are homework, quizzes, tests, and how much your teacher likes you. Again, not my class, just a different class. Let's just say that those were the grading criteria. And your scores in those 4 areas were 100%, 85%, 80%, and 95%. You could figure out your average. Again, if everything is equally weighted, you could figure it out by just adding up your scores. 100% plus 85% plus 80% and plus 95% divided by 4. Because again, those 4 categories are equally weighted. And you'd find that your score is equal to, that's going to give us 360 over 4. That's going to give us a 90% average. You have an A minus. Okay, great. But another way of looking at this is that you had 100 over 4 plus 85 over 4 plus 80 over 4 plus 95 over 4. You just take a quarter of each of these. That would be mathematically the same as what we have here. And that gives us a little bit of insight into the weighted average. Because let's just say that the test counted for 50% of your grade, the quiz is 25% of your grade, homework 20, and how much your teacher likes you is only going to be worth 5% of your grade. Well, if that's true, what we can do is we can take essentially this way of approaching it, but modify it. What if the 100% that you had weren't a quarter of your grade? What if it were something else? So let's modify this. Let's say, so we had a 100% average for your homework, and your homework is worth only 20% of your grade. So your overall percent is equal to, I'm going to say 20%, which is 0.20, times your homework grade, which I had said was you got a perfect score in your homework. That's 100%. So we have that, and then we're going to add to it your quiz grade. Okay, that was 25%. And your quizzes, you had scored 85. You were about a B on your quizzes. So we're going to say a quarter, 0.25, times your 85% average on quizzes. All right, that's the component from your quizzes. So this is HW, this is Q, plus 50% of your grade is tests. And 50% of your grade would be 0.50 times how well did you do on your tests? You scored 80% on your tests overall. So we have our 80 here. And now, this is for tests, and now the how much your teacher likes you. Okay, that is 5%, so that's going to be 0.05 times, I believe it was an 85, no, a 95%, times 95% was your score in that. So this is what we call our weighted average. And again, if everything were equally weighted, you just have 0.25 times your homework score, plus 0.25 times your quiz score, plus 0.25 times your test, plus 0.25 times this last category. But since they're weighted, we have different coefficients out in front. And this would end up giving us an overall average of 86%. So that's how you would figure out your weighted average for your grade in this fictitious class. And if we're trying to figure out a weighted average for atomic masses, it's the same, essentially. Now, if the two isotopes of chlorine were truly 50% of one and 50% of the other, if it were really true that in nature half of all the chlorine were chlorine-35 and half were chlorine-37, then you could take a simple average just like you're used to doing from math years ago. But since we know that 75.76% of all chlorine is chlorine-35, okay, so about 3/4 of chlorine is Cl35, and only just about a quarter is chlorine-37, we need to use a weighted average. So what we can do is say the average atomic mass is equal to that 75.76%, which I'm going to convert to a decimal, 0.7576 times that many atomic mass units, 34.9688 AMU, plus we have the remaining 24.24%, 0.2424 times the atomic mass of chlorine-37, which is 36.9659 AMU, and that is going to be our average. And just looking at it, this is about 35, this is about 37. We're not going to meet at 36 because it's not a 50-50. If most of the chlorine is chlorine-35, we should be closer to 35 than we are to 37. And if we were to calculate this out, what we would find is that we have 35.4529 AMU is what we calculate. Now granted, there are, well, 6 sig figs here, but the percentages are only 4 sig figs, So we have to cut it off at 35.45. So 35.45 AMU, and that would be our final answer. And if you were to look in the periodic table, you would find that the average atomic mass for chlorine is indeed 35.45 AMU. Hope this has been helpful.